Alrighty, everybody. In this video, we're going to set up the AI for our main enemy, which is going to be a little mailman guy for this little boss battle. We'll have to go back and modify the dog so that he can actually attack enemies, but I figured it'd be better to have something to attack before we set that up. So let's go ahead and I'm going to create I already have a sprite ready under my sprites folder in the project window, and I'm going to drag this mailman 0 into the scene. I'm going to just rename him mailman since he's going to be the only one. He appears really tiny and the dog's in front of him, so I'm going to scale him up like I did the dog. And then also change his sorting layer to player so we can actually see him. Just to make both of these guys visible, I'm going to move him a little bit to the left of the dog. Okay, and so this guy needs a script. So I'm going to go into the scripts folder and right click and create a C# script, and it's going to handle all of his AI. So I'm just going to call it the mailman controller. And that opened up Visual Studio, but not our script. There it is. I'm going to go ahead and attach the mailman controller to our mailman so that when we make changes to the script, we can see that reflected in the scene. Okay, not seeing the recorder made me a little nervous, so just brought that back. Alright, so if we have the script attached and we've opened it in Visual Studio, we can start maybe doing our pseudocode for what we want to do. So the two main things that we want is, if you remember back in the preview video of what's going to happen, this guy is going to have like two main states where he's sort of moving around the screen, and then he will switch state into where he's attacking, and he'll do an attack, and then after he's done with the attack, he'll go back to moving. So I'm going to make a function where I'm going to switch between behaviors or states. Attack versus move. Okay, so let's go ahead and then we'll lay out each of these, attack and move, and what that means. So let's make a function void. I'm just going to call it switch state, and have that set up here. Okay, so sorry, you're going to hear some slurps from me because I'm drinking coffee. How we're going to define the state that the mailman is going to be in is we're going to create what's called an enumeration, and basically it's a way for us, the keyword is enum, to create our own variables and like define what that sort of means. So I'm going to call this enum boss behavior, and then if we do the little squirrely brackets, we can name any amount of different variations of this boss behavior. So the first one is going to be attack, okay, and then the second one is going to be move. Once we've created this enumeration, we've defined what this enumeration means, but also this class, mailman controller, should have its own boss behavior. So we're going to make a public boss behavior, and we'll just call it boss behavior, but lowercase. And so we'll know that the capital boss behavior means the enumeration that we've defined, and the lowercase means a specific one in this class. And so the default, we're going to say he's going to move before he attacks. So we'll just set it equal to move. What's this error here? Oh, okay. It's giving us an error because we didn't make this public, and that needs to be accessible in order to have a public boss behavior. Okay, so the next thing we're going to do what's called a switch case. And switch cases are basically a way to lay out a bunch of if-elses. And in our switch state, when we switch, we're going to feed in a specific boss behavior. And depending on that boss behavior, we'll change some settings in the mailman and have them do different stuff. So when we do our function switch state, so scratch that. Like I'm not going to feed in a new boss behavior, but since we can reference this guy, we'll do different things depending on which one is the current state and which one is the state that we want next. So let's start setting that up. So we need a switch, and we will depend on our current behavior. We'll switch between back and forth between states. So this will be nice to set it up this way because later I'm going to have my class create different behaviors for this enemy, and so we can just line up more cases and we can add to this boss behavior to do different sorts of attacks and stuff like that. So I'm feeding in the boss behavior, and depending on which case, we're going to do something different. So when we do switch case, we always have to break from whatever case. So like after, if boss behavior ends up being move, then we do a bunch of stuff here, and then after that, we get out of the switch statement. So we can set up our next one here, in which we'll do case boss behavior dot attack. And break. Okay, it's a good time to do some pseudocode here. So and this, if we're already moving and we're triggering switch state, then we want to switch to attack. And then same for attack. If we're switching from attack, oops, I'm using the word switch a lot, aren't I? Switch to move. Okay, so if we're in move, we can change our current boss behavior to attack instead. So we'll do boss behavior equals boss behavior dot attack, and then we'll do the same over here. Our boss behavior that's attached to our class is boss behavior dot move. So now we switch between these two. Now might be a good time to set up a timer for how long it's going to take to switch between these two things. So at the top here, I'm going to create a public float, which is going to be our time in which we're going to switch states. So we'll do switch state time, and we'll say that's equal to 1. So just 1 second. And then we can, it's public, so in the inspector we can change what that's going to be. All right. So in update, we can decrement our switch state time, and then once it's hit 0, once we've counted down to 0, we can trigger a switch state. So in update, since that's called once per frame, we can do our timer countdown here. So we'll get our public switch state time, and we'll decrement that by the time it takes for each frame. So this is called once per frame. So if we decrement how long it took to do that frame, then we'll have a real time decrease. So the time for the last frame is time.delta time, and so that goes down, and if switch state time is goes below 0, then we want to trigger the switch state. So we'll say if switch state time is less than or equal to 0. We don't want to just say equal to, because this could go down below 0, so we want to also include less than. So if this is true, then we want to call our function switch state. Alright, so if we test this out right now, we should have a public behavior that's move, and then when 1 second passes, then it'll trigger a switch state and it'll switch to attack. So let's try that out. Let's see if our mailman has updated, and we've got a public time. We can test 2 seconds just to have enough time to see this change here. So it'll go from move 0 into attack, and now we're not changing the switch state time, so it's constantly switching because it's constantly below 0. So the next thing we'll want to do is we'll want to make the switch state time something above 0 again. And I think that's going to depend on what the boss is currently doing. So if he's moving around, we want to have him move around a certain amount of time before he attacks, but that might not be the same exact amount of time for how long he takes to attack. So the next thing we'll do in each of these switch statements is to set a specific switch state time. So switch state time, it's below 0, but now we're going to set it equal to, I'm going to try 2 seconds for attack, because he is being switched to attack, and I'll have 2 seconds to attack. And then over here, we're going to say he moves for 3 seconds, just to try that out. Now I'm hard coding this, but we could, no, why don't we do that now? We can make some more public floats in which we have different amounts of time, so we can say attack time and move time. And then we could set that in the inspector instead of having to go back here and change this value every time. So let's say switch state time is going to equal our attack time, and our switch state time is going to equal our move time up here. And then we'll just make sure in the inspector to change that to the appropriate values. So we said 2 seconds for attack time, and 3 seconds to move. So now if we test it out, should see it decrement to 0, but then also switch back to 2 or 3 and also switch between states like this. So we got a nice little timer set up for its different states. Now, depending on which state, we'll need to trigger a particular animation and also say whether he's vulnerable or not. So let's get the move working first. And what we want for his movement is to sort of go in a random direction, or start out in a random direction and just bounce off the walls. So what we can do is we can specify a random vector up here. So we're gonna make do this here, vector to randVect, and on our start function we can say that randVect is a new vector2, and we want to make a random direction within a certain amount of range. So we'll say a random dot range from -1f to 1f, and random -1f for both x and y. Make sure to have a semicolon there, and should be good. So we're getting a new vector that's random. If we think about it as different axes, the x can be either negative or positive, and the y can be negative or positive, with a maximum value of 1 in each direction. So that will give us a random direction for him to start. And we're going to move him in update. So if his boss behavior is move, then we can have him move randomly around the scene. So we'll say if boss behavior is equal to boss behavior dot move, and then we'll do some stuff here. So we're going to move him around based on the random vector, and we'll do transform dot translate. So translate, if you hover over it, you can see the description for this. So it's going to move our transform in the direction that we input, and the distance to translation. So there's a few different overloads we can look at. So we could feed in a direction, X, Y, and Z, and we can make it move relative to local space or world space or whatever. So what I want is I want to feed in our random vector, but I also want to, and whenever we feed in for translate, we have to multiply this by time dot delta time. So we move the transform based off of the time. So we'll give a consistent time to our movement when we're translating the position of this guy. But I also might want to change the speed of how fast he's moving. So I can set another public float over here, speed, and give it a default value of 1, and multiply that by speed. Okay, so now on update, it's going to check if it's in its move state, and if it is, then it's going to move around in a random direction. random direction that we've defined on the start function, the very start of the scene. So let's see, let's try that out. Sweet. A couple things is the speed is really small, so I'm going to boost that up. And as you can see, it's moving, but it's not staying within the bounds. So the same thing that we did with the dog, where we defined a bottom left and a top right corner, we can also do with our mailman controller. So we'll feed in a public transform over here. Of the bottom left corner and the top right corner. Okay, and in our behavior here, when we're moving our mailman around, we want to check if it's past the bounds or at the bounds. Okay, so what we're going to do is we're going to code in here. So we'll check for X first, and let's also think about what we want for each of these. So if we say he sort of like, we want him to bounce like this. So if he's going in this direction and he's below the X threshold, because this is the X axis of this boundary, then we want to move him back up in this direction. So we're going to keep the X actually the same because he's still moving left, but we're going to switch the Y to from negative to positive, so he bounces. And we'll do that for each of the walls. Like, we check for a Y boundary, keep the Y the same, but change the X, and then the same for the top and the left boundary. So we'll check for X boundary and switch Y direction if met, if the boundary is met. So if transform dot position dot X is less than the bottom left corner dot position dot X, or so that gets our bottom corner, this bottom X. We also want to check for this top X, so we can do a logical or. If transform dot position dot X is greater than the top right corner, dot position dot X. Now we can do something with this if statement. I didn't do squirrely brackets because if I only need one line, I can just specify one line, and the if statement will only do that one line. So our random vector, the vector that we're moving up here, we can switch that to a new vector, vector 2, in which so we've checked for the X boundary, and oh, so I was confusing myself. So we are checking for the X boundary, but this first example is left and right, not up and top and bottom. So if we've hit the left boundary, then we want to change our random vec to be a new direction, which is negative our x value and positive our y value. I'm going to go ahead and copy and paste this next guy. Actually, I can copy and paste even the comment, so that's clear. Now we'll check for the y boundary on everything. So every position x is going to be position y. And we want to change the y value to be the opposite instead of the x. Okay, that should work. We just need to feed in our two transforms for bottom left. Let it load, bottom left and top right. And I'm going to boost the speed up to 20 so we can see it a little faster. All right. Nice, he bounces around. One other thing that might be nice is for when he's switching states, instead of the same random direction throughout the entire battle, he can, when he starts up the state again, he'll do a new direction. So we can set random vect. We can set that to be when we switch it from attack to move, we can have this random vect be another random vector, and it'll switch between those. So if we save and try that out, we should see him sort of go in the same direction. One thing I'm noticing is that we're still getting different speeds, and we might be okay with that, but we might not. So what we can do to make it a consistent speed each time is if we change this vector to be a normalized vector, which means, like, let's say if we pick a random range and we have like 0.001 and here it's 0.2 or something, then that's much slower if we pick like -1, 1. So if we normalize this, then it will change our vector 2 into a vector that is consistent, a consistent size. And so to do that, we can just feed in with this vector 2, we can just say dot normalized, and then whenever we change it, we can make that also normalized. So we save it, Control S, go back, and we should see him speed the same, and he's really fast. But he's consistently fast. So then we can just change the speed down to like 10 or something, and he will be better. Yeah, it kind of happens. He's getting kind of stuck. Oh, I think I see what's happening here. So if we are changing based off of, if he's still moving and he's less than the boundary, he's like overtaken the boundary, and he doesn't have enough time to switch direction and recover within the same frame, then he is going to trigger this again, and then he will change from negative to positive to negative positive, and that's why we see that sort of squiggly movement. So what we'll need is to have change the behavior so to account for that. Alright, so what we're going to do is when the mailman has overcome a boundary and we switch directions, we want to ensure that when he switches direction, he's out of that case where he's still behind the boundary. So what we can do is, as soon as he's exited the boundary, before changing his direction, we can snap him to the position of the boundary before sending him on his way. That way it won't trigger this same condition every time. So we actually will need squigglies for this guy. And to make sure that your squigglies encapsulate both of these. I'm going to zoom out a second so you can sort of see that better. Squiggly, delete, squiggly. And it'll format it to like move the squigglies here, which is kind of nice. Alright, so before doing changing the direction, we're going to move the position of our mailman to vector 2, and we'll say we've checked for the X boundary, so we want to have our X position, the bottom left corner, be the exact same as the bottom left corner. Oh no, we have to check. For each of these because these are both going to have a different X. Alright, so instead of including this in the same statement, then we can break it up. So I'm going to delete this or, control X that guy, and we can make another if statement here where it's greater than the top right corner. Okay, so if it's less than the bottom left, we will change the position to be exactly the bottom left, and then transform dot position. We'll leave Y the same. Dot position dot X because it's a transform. And then we can copy this. Now if we will, since we're checking for the top right, then we'll make the top right corner exactly the position X, and then do the same with the new random vector. With this guy, again, we'll delete the or, cut that out, and then make another if statement. And we will update the transform position. Dot Y is going to be, not dot Y, it's going to be a new vector where we're going to keep the same X, and we will change our, we will snap to the bottom left corner Y. And a semicolon. And we can copy this as well. Transformed opposition, is top right corner. Alright. A little more complicated, but we can try that out now. It's one of those things where it might not be easy to replicate the problem, but if we ever see it doing that thing again, then we'll know we messed it up. But I think we got it right. Okay. I think I will end this video here. Next time we will plug in some animations to our mailman when he goes in between states. After that, we will set up the combat. Yeah.